Hi everyone, welcome to another video discussion. So in our previous discussions, we have already talked about the measures of central tendency, which were the mean, median, and the mode. We also talked about measures of dispersion, the range, the standard deviation. And in this video, we will be talking about measures of position, which are the quartile, decile, and the percentile, also known as the quantiles. So let's start with some definitions. So measures of position, again also known as quantiles, these are natural extension of the median idea in that they are values which divide a set of data into equal parts. So quantiles are classified as, so there are three types, which I have mentioned earlier. The first one is the quartile. The second one is the decile. Third one is the percentile. Let's start with the concept of quartile. So by definition, a quartile is a quantile that divides the distribution into four equal parts. The values of the quartiles are denoted by Q sub 1 for the first quartile, take note, Q sub 2 for the second quartile, and Q sub 3 for the third quartile. Okay, so that's Q for quartile. So for Q sub 1, 25% of the distribution falls below and 75% falls above the value of Q sub 1 or the first quartile. So to illustrate that one, let's say we have here a number line. This is Q sub 1. This is Q sub 2. And we have here Q sub 3. So just imagine that these are equal parts. So for Q sub 1, below Q sub 1, that's 25%. And the remaining parts above Q sub 1 is 75% of the distribution. Okay. For Q sub 2 or the second quartile, 50% of the distribution falls below and the other 50% falls above the value on the second quartile or Q sub 2. So for the second quartile, so 50% falls below it and 50% is above it. Okay. Third one, Q sub 3 or the third quartile, 75% of the distribution is less than the value of Q sub 3, while the remaining 25% is greater. So if we add these values, 25 and 50, that's actually 75%. That's below Q sub 3. And the remaining part right here, that's the remaining 25%. So if you can see, there are 1, 2, 3, and 4 parts. So just imagine that those are equal, okay? So the second concept or the second type of quantile is what we call as the decile. So by definition, a decile is a quantile that divides the distribution into 10 equal parts. So quartile, it divides the distribution into 4 equal parts, whereas the decile divides the distribution into 10 equal parts. The data set has 9 deciles, which are represented by D sub 1, D sub 2, D sub 3, and so on, up to D sub 9, where D is the number that divides the bottom 10 of the data from the top 90, and so on. So suppose we have a set of data. We have 1, 2, 3, 4, 5, 6, 7, 8. Sub 1 here, 9. So this is D sub 1, D sub 2, D sub 3, sub 4, D sub 5, D sub 6, D sub 7, D sub 8, D sub 9. So just imagine that these are equal. So this is first part, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and the 10th part of the distribution. So for D sub 1, or the first decile, 10% is below the value of the position of D sub 1, while 90% is greater than the value in the D sub 1 position. So here, below D sub 1, that's 10%. The remaining values above D sub 1, that consists 90% of the data in the distribution. For D sub 2, or the second decile, 20% is below the value in the position of D sub 2. So that's 10, another 10. So that's 20%, while 80% is greater than the value in the D sub 2 position. So above D sub 2, that comprises the remaining 80% in the distribution. For D sub 3, or the third decile, 30% is below the value in the position of D sub 3, while 70% is greater than the value in the D sub 3 position. So here, below D sub 3, that's 30%. The remaining 70% is above D sub 3. And that's the same concept for the remaining decile, okay? The third quantile is what we call as the percentile. So by definition, a percentile is a quantile that divides distribution into 100 equal parts. So I will not be creating an illustration, that will take time, but just imagine a set of data divided into 100 equal parts. So a set of data has 99 percentiles, which are denoted by P sub 1, P sub 2, P sub 3, P sub 4, and so on up to P sub 99. Okay? So for P sub 1, or the first percentile, 1% is below in the P sub 1 position and 99% is above the value in this position. So suppose you have this illustration. Let's just say this is P sub 1. So here we have 1%. The remaining set of data comprises 99%. Okay. For P sub 5, or the fifth percentile, 5% is below the value in the P sub 5 position, and 90%, or 95% rather, is above the value in this position. So let's say we have P sub 1 there, P sub 2, P sub 3, P sub 4, P sub 5. So let's extend that one up to P sub 99. So below P sub 5, or the fifth percentile, that comprises 5%, the remaining set of data comprises 95%. Okay. For P sub 60, or the 60th percentile, 60% is below the value in the P sub 60 position, and 40% is above the value in this position. So I hope you get the concept, okay? So just to recap, quartile, it divides the set of data into 4 equal parts. Decile divides the set of data into 10 equal parts. Percentile divides the set of data into 100 equal parts. So quartile is denoted by Q sub 1, 2, 3, and 4. Decile denoted by D sub 1, D sub 2, D sub 3, up to D sub 9. Percentile that's denoted by P sub 1, P sub 2, P sub 3, and so on up to P sub 99. Okay? So how do we solve for quantiles? So to solve any quantile, follow the steps below. Take note. Number 1, arrange the scores according to magnitude or size. Meaning to say, arrange the scores from lowest to highest, or highest to lowest. Either way, as long as they are arranged or they are in order. Second one, compute the position of the given quantile in the distribution using the appropriate formula. So there will be different formulas for the different quantiles. Third step, starting from the lowest score, locate the score corresponding to the obtained position in the array of data. So what we'll be computing first is the position, okay? And fourth one is interpolate to get the score of the obtained position in the distribution. So to get the exact score of the position of that certain data, we need to interpolate or to solve further. Okay. So we have here quantiles for ungrouped data. So same with measures of central tendency, measures of variability. We have grouped and ungrouped data. So ungrouped data are those data, usually a small amount of data, which we can treat, we can solve right away. Whereas group data are those data which we put in the frequency distribution table. We arrange it in a table because we have a large amount of data. So let's start with quartile. This is the formula. That's the quantity of I over 4 times n plus quantity of 1 minus I times 4. That's the position of the item or the data. Take note I, 1 for q sub 1, 2 for q sub 3, 3 for q sub 3, depending on what quartile, the position of the quartile we are looking for or we are solving for. N is the number of items. So the total number of items or the total number of data in our distribution. So for example, if we are solving for the first quartile, q sub 1, so simply substitute I with 1. So that's 1 over 4. N is unknown because we don't know how many items or how many data there are. So here also substitute I with 1. That's for the first quartile. Same with the second quartile, simply substitute I with 2. Okay? For the decile, by the way, take note, for quartile, the denominator here is 4. That's the indication that we are solving for the quartile. Whereas for the decile, the difference is that the denominator now is 10. Since, again, decile divides the distribution into 10 equal parts. Still the same formula, actually. The only difference is the denominator, the indicator as to what type of quantile we are solving for. So still substitute I with 1, 2, 3, 4, 5, 6, 7, 8, and 9, depending on what position or what decile we are looking for. So for example, for the first decile, which is d sub 1, so simply substitute I with 1. For the fifth decile, simply substitute I with 5. And don't forget that the denominator is 10. Okay? For the percentile, so same with decile and quartile, we have the same formula. The only difference is that the denominator now is 100 because we are now solving for the percentile. Now for I, depending on what position or what percentile we are looking for, simply substitute I with numbers 1 to 99. So that's 1 for P sub 1, 2 for P sub 2, 3 for P sub 3, and so on. So suppose we are solving for the 25th percentile, that's P sub 25. So we have 25 over 100. Okay? So if we are solving for P sub 30 or the 30th percentile, that's simply 30 over 100. Okay? Take note of the following. The first quartile is equal to the 25th percentile. So 1, 2, 3, Q sub 1, Q sub 2, Q sub 3. So this is P sub 25. This is P sub 50. This is P sub 75. Okay. So again, the first quartile Q sub 1 is equal to the 25th percentile. They are equal. The second decile is equal to the 20th percentile, and the 50th percentile is equal to the 5th decile. So there are quantiles that are equal depending on the given position. So let's have an example. Let's consider the scores below. So we are given the set of scores. Let's say these are the scores of the students in a certain exam or a quiz. We have the numbers 50, 52, 48, 45, 33, 65, 42, 37, 69, 40, 41, and 38. And we are tasked, or we are asked to solve for the following or find the following: the first quartile, third quartile, second decile, fifth decile, 20th percentile, and the 40th percentile. So how are we gonna solve for those? So we have here our solution. So again, in order to solve for quantiles, the first thing that we have to do is to arrange the set of data, either from lowest to highest or from highest to lowest. So here we have the array. Array meaning that the set of data has been arranged. So we start by or with 33, 37, 38, 40, and so on up to 69. So here we are solving for the first quartile or Q sub 1. So our indicator here is that our denominator is 4 because that is 4 quartile. So all you have to do is to substitute the I in the formula with whatever position we are solving for. Now, since this is the first quartile, so simply substitute I with 1. So we have 1 over 4 times n. So n is the total number of data. So here we have 2, 4, 6, 2, 4, 6, 8. So for how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 12. Sorry. So we have 12. So that is our n. So simplifying, that's 1 over 4 times 12. That is 3 plus, that's 1 minus 1/4. 1 over 4 is simply 0.25. So 1 minus 0.25, that is 0.75. So adding, we have 3.75. So our first quartile lies in the or 3.75th item. So 3.75, take note, is between the third and the fourth item. So third item is 38. Fourth item is 40. So since it's in between those two numbers, we need to interpolate. We need to solve further. So how do we do that? So since 3.75 has decimal 0.75, interpolate to find the value in the or in this position. So first is find the difference between 38 and 40, which is simply 2. Okay, so find the difference between the two succeeding numbers. Second one, multiply the difference by the decimal 0.75. So the difference is 2 times 0.75, that's 1.5. You can double check that one in your calculators. Then lastly, add the product to the smaller value, which is 38. So the smaller value is 38. You add 1.5, that will give us 39.5. So that means that Q sub 1, which is the 3.75th item, is 39.5. So that means that 25% of the distribution is below 39.5 and 75% is above 39.5. That means to say that our first quartile is the 3.75th item or 39.5. Okay. Another example, still the same set of data. Let's solve for Q sub 3 or the third quartile. So simply substitute I with 3 because we are solving for the third quartile. Okay. Then our N, that's still 12. Since we still have 12 items or the data in our distribution is 12. So simplifying, that's 3 times 12, that's 36, divided by 4, that's 9, plus 3 over 4, 3/4, that's 0.75. So 1 minus 0.75, that is 0.25. So our third quartile is in the 9.25th item. So 9.25 is between the 9th and the 10th item. So the 9th and the 10th items are here, 50 and 52. So to find the exact value, again, we need to interpolate. First, subtract 52 minus 50, that's 2. Multiply the difference with the decimal, which is 0.25. So 2 times 0.25, that's 0.5. Again, you can use your calculators if you're not familiar or you're not a master in terms of decimals. Then after that, add the result to the lesser number, which is 50. So we have the answer of 50.5. So that means that 75% of the distribution is below 50.5 and 25% is above 50.5. So the third quartile is in the 9.25th item or 50.5. Next, we have the decile. So solving for the second decile, d sub 2. So simply substitute the denominator by 10. So instead of 4, which was for quartile, this time use 10. Okay. And since we're looking for the second decile, our numerator is 2. Same with here. Okay. N is still 12 because there are still 12 items or 12 numbers in our data set. So yeah, you can actually use your calculators for this, but let's simplify. 2 times 12, that is 24, divided by 10, that is 2.4, plus 2 minus 10, 2 over 10, that is 0.2. So 1 minus 0.2, that is 0.8. Okay. Then adding those together, that will give us 3.20 or the 3.20th possession or item. So 3.20 is between the third and the fourth items, 40 and 38. So interpolate, subtract 40 minus 38, that's 2. Multiply with the decimal, that's 2 times 0.20 there. That's 0.4. Then add to the lower number. So 38 plus 4. 0.4. I mean, it's 38.4. So meaning 20% of the distribution is below 38.4. 80% is above 38.4. The second decile is in the 3.20th position or simply 38.4. Okay. Next, we have the fifth decile. So simply substitute I with 5 here. Denominator is 10, that's for decile. N is 12 because there are 12 numbers or 12 items in our data set. So simplifying, that's 6.5 or the 6.50th item or possession. So 6.5 is between sixth and seventh items, 45 and 42. Subtract, that's 3. Multiply 3 with the decimal, 0.5 there. It's 1.5. Then add 1.5 to the lesser number, which is 42. So that's 43.5. Okay. Next, we have percentile, solving for the 20th percentile. So simply substitute I with 20 and the denominator by 100 because this time you're solving for the percentile. Okay, so still the same process. It's 3.2 or the 3.20th item or position. Interpolate. So 3.2 is between the third and the fourth item. So that's 40 and 38. Subtract, that's 2. Multiply 2 by the decimal point, which is 0.2. So that's 0.4. Then add 0.4 to the lesser number, which is 38. So that is 38.4. Okay. So last one, we have the sub 40, the 40th percentile. So substitute I with 40. Then substitute, or the denominator is 100. That's 4 percentile. And it's still 12 because again, there are 12 numbers in our data set. So simplifying, that is 0 point, no, that's 480 divided by 100. It's 4.8 plus 40 over 100, that's 0.4. 1 minus 0.4, that's 0.6. Then 4.8 plus 0.6, that is 5.4 or the 5.40th position. Now 5.40 is between the fifth and the sixth items, 41 and 42. So interpolate. 41 minus 42 minus 41 is 1. Multiply 1 by the decimal point. This should be 0.4. So 1 times 0.4, that's still 0.4. Then add to the lesser number, it's 41.4. So that means this is the 40th percentile, that position, 41.4. Meaning 40% of the distribution is below 41.4, 60% is above 41.4. So that's measures of position for ungrouped data. Let's go ahead with quantiles for group data. So quantiles for group data are computed in the same way the median is computed, but in this case, instead of finding the median class, which is n over 2, in quantile, the quantile class is determined. So how do we do that? To compute for the quantiles for group data, number 1, determine the quantile class. Number 2, apply the procedures in solving for the median of group data. So for example, for the first quartile class, that's 1 over 4 times n, 1, because it's the first quartile, 4, because there are 4 equal portions in the distribution, then times n, which is the number of data in our data set. So find the cumulative frequency in which the result belongs in the class, in that cumulative frequency is the first quartile class. So for the second quartile class, that's 2. Okay, that's the second quartile over 4, because that's quartile, times n, a total number of data. So same with the other quantiles. So we have here some formulas. So for the first quartile, that's LB. Do you still remember this one? That's the lower boundary. Plus quantity of n minus 4. Okay, that's the location of the quantile class. minus less than cumulative frequency. So the cumulative frequency below the quantile class over F sub QC. Take note, F sub QC is the frequency of the quantile class times C. So those are the formulas. So for you to better understand, we have here an example. Okay. So in the following distribution, so we are given this set of data, okay, and compute for the following. Can you still remember how to get the cumulative frequency? So for the first one, just copy 5. Then add it to the second one, 7, that's 12, plus 10, that's 22, plus 8, that's 30, plus 6, that's 36, plus 4, that's 40. So the last entry here should be the same with the total number of items or the total number of data set. Okay. So for the first one, for the second quartile or Q sub 2 for this group data. So first is find the second quartile class. So since we are looking for the second quartile, that's 2, okay? Times n, which is the total number of data in our distribution, over 4, because we are solving for quartile. So that's 2 times 40, because there are 40 data set, over 4. That gives us 20. And 20 is in 22 cumulative frequency. So here. So 20 belongs in this quartile class. Okay, therefore, 42 to 49 is the Q sub 2 for the second quartile class. And its lower boundary is 39.5. Can you still remember? So lower boundary is get the lower limit, then subtract 0.5. So that's why we have 39.5. So to solve for this one, that's Q sub 2 is equal to the lower boundary. So again, get the lower limit, 40 minus 0.5, that's 39.5 right here. So this one, that's the quartile class. We have solved that one earlier. It's 20 minus less than CF. So cumulative frequency here is 22. Less than that, we have 12. Okay, that's why we have 12 here. Over 10, that's the frequency of the quantile class. So this one, it's 10 times 10, which is C for the frequency. Okay, so simplifying, we have 47.5. Okay, we have here another example. So letter B, solve for the third decile or D sub 3. So to find the D sub 3 class, again, still the same formula, but substitute this number right here with 3 because we are looking for the third decile. Still times n, total number of data in our distribution, dividing it by 10, since for decile there are 10 total for equal parts in the distribution. So earlier we had 4 because that was for quartile. This time we have 10. So simplifying, we got 12. So the class in the 12 cumulative frequency is 30 to 39 right here. Okay, 12. Frequency is 7. Lower limit and upper limit is 30 to 39, or the class interval. So D sub 3 is the third decile. Lower boundary is 29.5. So why is it 29.5? Again, for the lower boundary, get the lower limit. That's 30. Then subtract 0.5. That's why we have 29.5. So for our formula, that's d sub 3 equals lower boundary. Again, that's 29.5 plus the quantity. We already know this one. We have solved this one earlier. That is 12. Then minus less than CF, okay? So that's the cumulative frequency less than the quantile class. So that we have 5, okay? Then dividing it by 7. So 7 because that's the frequency of the quantile class, okay? Times 10. So simplifying, we have the final answer, okay? By the way, guys, 10 right here, that is the class size, meaning how large the interval is from the lower limit going to the upper limit. So that's the same for all intervals. Let's have the third and the last one. So the 70th percentile. So we have here 70 because we are solving for the 70th percentile times 40 because there are 40 items in our distribution. It's 70 times 40 divided by 100 because we are solving for percentile. So 100 is for percentile. So if you solve that one, that will yield 28. And 28 is in the 30 cumulative frequency. Let's see. So yeah, 28 belongs there. Frequency is 8. Class interval is 50 to 59, meaning our lower boundary is 49.5. So lower boundary always subtract 0.5 to our lower limit. So lower boundary, again, that's 49.5, as I've told you. Okay. Then this one right here, we already know the answer since we used that one to get the quantile class. That's 28. Then less than cumulative frequency. So frequency right here is 30. Less than that, we have 22, right? 22 divided by 8. 8 is the frequency here. Okay. Then 10 right here, again, that's the class size or the class width. That's the same for all. Since 10 is the interval between the lower and the upper limit for all class intervals. Then simplifying, you can use your calculators. Let's use our calculator here for the third example. So that is 49.5 plus 28 minus 22. Divided by 8 times 10. Oh, what happened? Wait, 49.5 plus 28 minus 22 divided by 8 times 10. Maybe we have to do this one by one. 28 minus 22 divided by 8 times 10, then plus 49.5. So that is, yeah, that is 57. Okay. So we have here exercises below. You can actually go ahead and practice on your own. If you have questions, clarifications, you're always free to ask in the comment section below or in our group chat. So that's it for my discussion. Once again, that was measures of position, the quantiles, which are quartile, decile, and percentile, both for ungrouped and grouped data. Thank you so much. I hope you learned something. You take care always. Bye-bye for now.